Hello girls, welcome to Digital Learning Day. Today we're going to continue on chapter 5.4, Dividing Polynomials, part 2. So this is just, what we're going to do today is another method of division that is actually a little bit easier than what you learned last class. It is called synthetic division. Sorry about that. It is called synthetic division. And it does have its limitations. It can only be used when you're dividing by a linear expression, which means, as we know, linear means x to the first. So it means you have to be dividing by something just x to the first. So it couldn't be any greater than that. But it is what's used most often. And like I said, it's a little bit easier than long division that we learned last time. This first slide is just instructions in words, which again, as usual, like I've told you, I'm not really going to go through these. They are here for you if you need them. It just kind of explains what we're going to do through our examples. So let's get started on the first example on page 2. So again, the problem looks just like it did in long division. We're dividing this polynomial by x minus 4. So I want you to just follow along with exactly what I do. And I'll explain it as it happens. So first thing, we are dividing by x minus 4. So we're going to take the opposite sign of this. Instead of minus 4, we're going to actually write a plus 4 and put it in a little box off to the side. Now, what we're going to do is take the coefficients of our equation, so 2, -3, -18, and -8, and we're going to write them right alongside that 4. So 2, -3, -18, and -8. Then we're going to draw a total line, leave a little space, and now we're going to begin. So first step, we're going to bring down this 2, write it down here, and we're going to, and first step is to multiply 4 times 2 is 8, and write the 8 right here. Now we're going to add -3 plus 8 is positive 5. Next we're going to multiply again. 4 times 5 is 20. We're going to add down. -18 plus 20 is 2. We're going to multiply again. 4 times 2 is 8. And add again. -8 plus 8 is 0. So now what we have here at this line is now the coefficients of our answer. So we're ready to write our answer out. And since we started with an x to the 3, we subtract 1 from that degree, and we're going to start our answer with x to the second. So we pull down this coefficient, and it becomes 2x to the second plus 5x to the first plus 2, and this last column is our remainder, which in this case is 0. So what we have is 2x to the third minus 3x squared minus 8x minus 8 divided by x minus 4 equals 2x squared plus 5x plus 2. So as you can see, it's a little bit easier. We don't have to set up long division. There's only really one step. And we really don't use variables in our equation until the very end. Okay? So let's try another one. Okay, again, here's our problem. We still need to check for missing terms like we did with long division. So before we set up our problem, we're going to look at, we have x to the third minus x to the second, but we don't have an x to the first term. So we're going to need to insert that, a 0x term to hold that spot, plus 12 divided by x minus 1. So as we set up our problem, again, we're dividing by x minus 1, so we're going to set up a positive 1. Again, we just use the opposite sign. Now we bring down our coefficients. We have a 9, so we bring down the 9, minus 21, 0, 0, 12, 12, draw a total line, and begin. So first step, we bring down that 9. We just write it down. And we multiply. 1 times 9 is 9. Negative 12 plus 9, negative 21 plus 9, sorry, is negative 12. We multiply again. 1 times negative 12 is negative 12. Add 0 plus a negative 12 is negative 12. 1 times negative 12 is again negative 12. Negative 12 minus 12 is 0. So here's the coefficients of our answer. Again, we started with an x to the third, so our answer begins with 1 less than that, which is x to the second. So we have 9x to the second minus 12x. Again, we just go decreasing degrees, minus 12. And our remainder is 0. Your remainder won't always be 0, but when it is, it means the same thing as it did in long division, in the fact that if it's a remainder of 0, then x minus 1 is a factor of the equation we started with. So 9x to the third minus 21x squared plus 12. Okay, so same result when you have a remainder of 0. Okay? Now let's go to the next page, and we're going to use this fact to to go a little bit further. So we can use synthetic division to completely factor polynomials when we have that remainder of 0. So let's show that in this example. So again, first thing we do, we look at, first let's see if we have any missing terms. We have an x to the third, x to the second, x to the first, and 0. So nothing missing there. So we can go ahead and begin. So we have x plus 5. So we're going to set up our divisor as minus 5. Again, we just use the opposite. Now we set up our coefficients. We bring down our 1, our 3, our negative 13, and our negative 15. Skip a little space, draw a line. Now we can begin. We bring down our 1. We bring down our 1. Sorry about that. Bring down our 1 and multiply. Negative 5 times 1 is negative 5. Then we add 3 plus a negative 5 is negative 2. Then we multiply again. Negative 5 times negative 2 is positive 10. We add negative 13 plus 10 is negative 3. Negative 5 times negative 3 is positive 15. We add negative 15 plus 15 is 0. So now when we create our answer, again, we started with x to the third. So our answer will be 1 less degree. So it will be x to the second. So we bring down our 1x to the second and then decreasing degrees from there, minus 2x minus 3, and a remainder of 0. Now, one thing I want to add is as you build your answer here, you should always start with 1 less than the degree you started with. So again, x to the third, I'm starting with x to the second. And then take care of every term below that, and you should always have 1 column left over for your remainder. It may be a number, it may be 0, it doesn't matter. But you must have an extra column after you've assigned all of the terms. If you don't have that extra column, it may mean that you were missing a term in your original equation that you didn't account for. So just something to be aware of. Now in this problem, since it asked us to use synthetic division to completely factor, then we want to look at this, our answer, and see if we could factor it further. And again, if we look at this, it is a quadratic, 3 terms with no number in front, or a equals 1. So we know we can further factor that with the magic question. So we can think what multiplies to negative 3 adds to negative 2, and we have negative 3, positive 1. So we can write that as those factors as x minus 3, x plus 1. And we also know that X plus 5 is a factor because of our remainder of 0. So we can add that to our list. So all three factors, so we have found all three factors of our original equation. And again, it's an x to the third, so we expect three factors. And using synthetic division, we're able to factor completely. Okay, one last example to show you a couple different scenarios you might encounter. If we look at this equation, we have x to the third minus 1. So it's kind of obvious we're missing some terms, right, between an x to the third and a constant. So we want to think about this problem actually as x to the third plus 0x squared plus 0x minus 1 divided by x plus 2. So as we set up our problem, again, we're going to, since we're dividing by x plus 2, we take the opposite sign and set up a minus 2. We bring down our coefficients, so we have a 1, a 0, and a negative 1. Draw our total line, bring down our 1, and multiply. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. And we add to get negative 9. So again, these are the coefficients of our answer. Since we started with an x to the third, again, our answer will be 1 less than that. We'll start with x to the second. So we bring down this 1, and we get 1x to the second minus 2x plus 4. However, this time, in this last column, we have a remainder of negative 9. So since we have a remainder, that's fine. We've done the division correctly, except that we know with the remainder, we know that x plus 2 was not a factor of x to the third minus 1, which is okay, just like we learned in long division. It's just that there's no way we could go any further with this then, since it's not a divisor. So this is a couple examples of synthetic division. What I'd like you to do now is the homework assigned in your book is page 308, 18 through 30, evens. And again, this is all written on SchoolFusion. So give them a try and see how you do. If you have any questions, again, you can shoot me an email during the times I have listed on SchoolFusion, and we will go over all of this on class next time I see you, which should be Tuesday. So have a great digital day, and I'll see you hopefully tomorrow. Bye.